Hello everyone, welcome to today's class. Today we are going to look at geometry, but before we continue with different topics in geometry, let us make a little review on angles, because angles are the integral part of this topic. Okay, so we are going to make review on different kind of angles so that when we dive into the topic properly, we are not going to be having any challenges. Might be asking, what's an angle? In case if you don't know what an angle means, when a line meets another line, is going to there will be an angle there. So what that means is that when a line meets another line, whether it crosses or it just stops at the point of meeting, okay, this point we call it intersection. So this point is point of intersection. There is an angle here, there's an angle here, okay? So whenever a line meets another line, okay, or intercepts another line, there is an angle formed. So the second type of angle we are going to look at is a right angle, okay? So what is a right angle? A right angle is any angle that is equal to 90 degrees. Most times you will not be seeing 90 degrees anywhere. What you will be seeing is a block like this, okay? So whenever you see this sign is a right angle, it simply means that that point there is what? 90 degrees. We also say that the two lines are perpendicular to each other, okay? Whenever two lines meet and they form 90 degrees to each other, we say that the two lines, that line 1 and line 2, are perpendicular to each other, okay? So let us look at the third type of angle. So our third type of angle is what we call obtuse angle, okay? An obtuse angle is an angle that is greater than 90 degrees but less than 180 degrees. So any angle or any value of angle that is between 90 to 180 is regarded as what? An obtuse angle, okay? So this is how it will look like. You can see that it is a little bit more than 90. So anything from here, which is 90 degrees, to here, so if you move from here to here, that will give you 90 degrees. Then anything more than that will give you obtuse angle, okay? So let us look at the fourth one. So the fourth and the last type of angle is what we call a reflex angle. So a reflex angle is any angle between 180 to 360. So any angle that is more than 180 but definitely less than 360 will give you a reflex angle. So that's the example of a reflex angle. Now, after this, we are going to look at theory of angles, okay? Theorem of what? Angles. That's what we are going to look at next. Okay. So the first theorem of angles that we're going to look at is sum of angle at a point on a straight line, okay? Yes, I know that we are familiar with calling it sum of angle on a straight line, but I think sum of angle on a straight line confuses students, okay? So it's better we say sum of angle at a point on a straight line, because if you look at the angles, they are all meeting at a point on the straight line, okay? Because sometimes when we have something like this, and we have this angle and we have this angle, when the younger ones, when they hear sum of angle on a straight line, they will tell you that these angles are on the straight line, that the sum should be 180. So I think the better way to uh, tell the younger ones is that is the sum of angle at a point on the straight line. The sum of angle at a point, you can see this one here. So if I have here A, I have here B, I have here C, I have here D, I have here E, that these angles are at a point that is on a straight line, okay? So they are all on a straight line, but they meet at a point. That the sum of this angle will give us 180. So A plus B plus C plus D plus E will give us 180, okay? So that's the best, that's the better way. I feel is the better, I don't know the best. So it's a better way of stating that particular theorem, okay? So we are moving to the next one. The second one we are going to look at is sum of angle at a point. not on a straight line, at a point. So the next one we are going to look at is sum of angles at a point. So it's no longer on a straight line now, it's at a point, just at a point. So you can see that this is our point there. So we have it that the sum of angle at a point is equals to 360. So what it means that if you have angles at a, it can be just two angles, it can be three angles, it can be four angles, it can be five angles, so long as they are all meeting at a point, that the sum of the angles that they will produce will give you what? 360 degrees. Okay, so let us look at the next theory of angle. So before we move to the next theorem, let us look at what we call parallel lines and perpendicular line and a transversal line. Okay, what is a parallel line? When you have two lines, that the distance between this line, let's call this line 1 and call this line 2, at any point that the distance are equal, at any point the distance are equal, so if D1 and D1, D2, D3 are equal, okay, so let's call it D1, D2, and D3. If they are all equal at any point, then we now say that line 1 is parallel to line 2. So when we say that two lines are parallel, is when the two lines, the distance between the two lines are equal at any point. Okay, so what does that mean? It means that line 1 and line 2 can never meet at any point. So when you keep drawing this, so long as the distance are equal, they are going to keep maintaining that level of distance without meeting. So we see that the two lines are what? Parallel. Now we have a symbol we use for it. So you can say that line 1 is parallel to line 2. So this is the symbol we use for parallel lines, okay? And most times in mathematics, we use an arrow to show that two lines are parallel. So whenever you see an arrow like this, it simply means that the two lines are what? Parallel. It simply means that the two lines are what? Parallel. Now, what of when you draw a line, okay, that cuts the two parallel lines? So any line that cuts the two parallel lines, I did not say cut into two, that just pass through a straight line that pass through two parallel lines, they are called a transversal line. They are called what? A transversal line. So these two lines here are called parallel line. So these two lines are called parallel lines. Okay. Then the line that cuts through a parallel line is called a transversal line. Why I'm explaining this is because we are going to get this next theory of angle from this parallel line that have been cut by a what? A transversal line. Okay, so let us look at the next theory of angle that we have. So what do we call vertically opposite angles? Okay, but before we talk about this vertically opposite angle, let's indicate the angles that have been produced when this transversal line cut this parallel line. So let me clean this so that we can have a free space there. So let me put my arrow here, okay, where it will not. Okay, so let's call here angle A, call here angle B, call here angle C, call here angle D. Let's call here E, F, G, and what? H. Okay, so we use A, B, C, D, E, F, G, H to indicate the angles that have been produced when a transversal line have cut two parallel lines. Okay. Now remember, we can have more than two parallel, we can have three parallel lines, we can have four parallel lines, but let's just use these two parallel lines to illustrate what we are trying to discuss. Okay. So when do we have vertically opposite angles? Vertically opposite angle is any time that you have two lines that cross each other. Okay, you can see it here. We have a vertically opposite angle here. We have a vertically opposite angle here because there are two lines that cross each other. So whenever you have two lines that cross each other, that is vertically opposite angle. And where is the vertically opposite angles here? This angle here and this angle here, they are vertically opposite. So let's use X and Y to denote that. So they are vertically what? Opposite. So if they are vertically opposite, what happens to vertically opposite angle? What is the theorem behind vertically opposite angle? The theory behind vertically opposite angles are they are equal. Okay, so anywhere you have vertically opposite angles, they are what? Equal. A vertically opposite angles are equal. Now, using this our diagram here, okay, so let's use this our diagram. Therefore, from the diagram, we now say that you can see that A and D are vertically opposite. So A equal to D, that's not the only vertically opposite angle here. B and C are vertically opposite. Okay, then here you can see that E and H are vertically opposite. So E equals to H, and here we can say that F and G are vertically opposite. So these are the vertically opposite we can get from there. Okay, so let us look at number 4. Number 4, let's look at corresponding angles. Let us look at corresponding angles. When do we have corresponding angles? Now, vertically opposite happens at a particular point, okay? But corresponding angles, we have to consider the other points, meaning that an angle here have to be corresponding with an angle here, okay? An angle here have to be corresponding with an angle here. Now, there's a way I describe this to my students, okay? I always say, when we say corresponding means that if I bring out my right hand and you bring out your right hand, that means we are bringing out the corresponding side of our hands. Okay. If I jump up and you jump up, we are doing a corresponding activity. Okay. So corresponding angle is that when you come to this point and you come to this point, whichever position the angle is at this point, it will be at the same position with this point. What does that mean? I'm here, you are there. If I bring out my left hand, you bring out your left hand. If I raise it up, you raise it up. That means we are bringing out the corresponding part of our body because it's our left hand and you have your left hand. I raise it up, you also raise it up. So we are doing corresponding activity with corresponding part of our body. Now, if you look at these 2 points, okay, so because there's a point here and there's a point here. So if you look at these 2 points, you will notice that the B is on the right side of point B. So this on the right hand side, this left hand side, B is facing up part while D is facing down part. So if you come to this point also, you notice that E is also at the right hand side and also facing up, just like B. So if you look at B and E, they look alike in their respective points, okay? Therefore, we say that they are corresponding. So we say that corresponding angles are equal. So corresponding angles are equal. So there are a lot of corresponding angles here. Let's fish them out. So B equals to E, so they are corresponding, okay? A equals to F, they are corresponding. We also have that D equals to G, they are corresponding. and we also have C equals to what? H. They are corresponding. So these are all the corresponding angles we can get here. Let me repeat what corresponding angle is again, or how to identify it. You can see that the position, look at this point here, look at this point here, okay? So let's call this point X, and let's call this point Y. At point X, you can see A, okay? A is on the left-hand part of that point and upper part, okay? Because we have 4 parts, up, 2 down, okay? 2 left, 2 right. So you can see A is at the upper part and at the left-hand side. Then when you come to point Y, you can also see F is at the upper part of point Y and also at the left-hand side of point Y. So long as they share the same position in common in their respective points, and the two lines are parallel, and there's a line is one line that cuts across X and Y, that's point X and Y, therefore those two angles are corresponding. Okay, now the next one we are going to look at is what we call alternate angles. So let's write it. Now, just like vertically opposite corresponding angle, alternate angles are equal. Okay, alternate angles are equal. Then I say just like vertically opposite angle, corresponding angle, alternate angle are also what? Equal. But unlike corresponding angle, that the position of the angle at point X and the position of the angle at point Y have to be the same in their respective points. Okay, but in alternate angle, it have to be opposite. What does that mean? If this point is on the left hand side here, the angle that it will be alternate to is going to be at the right hand side. If this one is facing upwards, the angle that is going to be alternate to is going to face what? Downwards. Okay, so if you look at that very well, you will notice that D and F are alternate. Okay, D and F are what? Alternate. So look at this point X, this point Y. D is at the right hand side of point X, while F is at the left hand side of point Y, which is opposite. D is toward the down part, okay, the lower part, while F is the upper part, okay. So they have opposite, okay, opposite position in their respective points. Therefore, D and F are what? Alternate angles. Okay, so you can as well identify other alternate angle with that method. If I pick A and ask myself, where is A? A is at the upper part. That means the angle that it will be alternate to is going to be at the lower part. And A is at the left hand side of that point. That means the angle is going to be alternate to will be at the right hand side of the other point. Okay, so therefore A and G are what? Alternate angles. So let's list out the alternate angles we have there. So we say A equals to G because they are alternate. D equals to F, they are alternate. C equals to E, they are alternate. And B equals to H, they are alternate. Okay, so we have one more angle to discuss from here. So let us clean the board and discuss that last angle that we can get from here. So the fourth is what we call co-interior angle. Now, we call it co-interior angle. Some people actually call it adjacent angles, okay? Adjacent angles, because the angles will be, they will be adjacent to each other. So I'm standing here, the angle is there, so we are adjacent to each other. Okay. So if you look at the diagram, you will notice that we have angles that are like that. E and D, they are on the same side. Okay. So they are adjacent to each other. So co-interior angles. So co-interior angle sums up to what? 180. So what does that mean? From what we have here, D plus E will give us 180 degrees, and also F plus C will give us 180 degrees. Now, if you look at that diagram there and look at the angles, there are other angles that can also sum up to give us 180 degrees. So you can see that A and G and H, A and H will give us 180 degrees. B and G will give us 180 degrees. Okay. So this diagram will help you to learn all the angles. So you can get your sum of angle at a point on the straight line. You can see that A and B are on the straight line. So the sum of these two angles will give you 180. You can have another straight line here, okay, and they're meeting at this point. So the sum of these two angles will also give you 180. We also have sum of angles at a point, okay. We also have sum of angles at a point. So all these angles here, they all sum up to meet at this point. So the sum of this angle will give you what? 360. So this diagram helps in explaining a lot on angles, okay? Explaining a lot on angles. Now, that is where we are going to stop on theories of angles, okay? We are going to stop here on theorems of angles. Let us look at the next topic on geometry.